We use them every day to pack our lunches, store leftovers, or deliver takeout. Plastic food containers are everywhere. But what if we told you some of them were made from yesterday's trash? That soda bottle you threw away last month, it might be holding salad today. In this episode, we go behind the scenes to uncover how discarded plastic, once destined for landfills or oceans, is collected, purified, melted down, and reshaped into safe, durable containers fit for your fridge and your microwave. From curbside bins to cutting-edge machines, and from dirty waste to food-grade clean, it's a journey of transformation that combines recycling, chemistry, and precision engineering. This is more than just plastic, it's a second chance. Welcome to How It's Made, recycled plastic food containers. The journey of a recycled plastic food container starts long before it reaches the factory. It begins at the curbside. Across neighborhoods, cities, and commercial zones, used plastic bottles, food packaging, and containers are dropped into recycling bins. These items are then transported to regional materials recovery facilities, where the transformation begins. Upon arrival, the plastic waste is unloaded in massive piles and pushed onto conveyor belts. The first round of sorting is mechanical. Large spinning drums separate light materials like film plastics from heavier objects. Magnets pull out any stray metals. Then comes the key step, optical sorting. High-speed infrared scanners detect the type of plastic based on how each piece reflects light. Once identified, powerful air jets separate PE, polyethylene terephthalate, from PP, polypropylene, and so on. These are the two most commonly recycled plastics used for food containers. Manual workers follow, picking out non-recyclables, dirty items, or anything that could contaminate the batch, like greasy pizza boxes or foil. The selected plastic is then grouped by polymer type, color, and grade, and moved into separate holding bays. Any container that once held chemicals, paint, or hazardous material is discarded, because only the cleanest feedstock can become food-safe again. Once sorted, the plastic heads for a thorough washing and shredding process. But even at this early stage, the path from trash to table has already begun. Once the plastic has been sorted by type and quality, it moves into the next phase, transformation. Large conveyor belts carry the selected plastic into a granulator, an industrial shredder with sharp rotating blades that pulverize bottles, trays, and containers into small flakes, each about the size of a fingernail. This process dramatically increases surface area, making the next steps more efficient. But before these flakes can be remade into food-grade containers, they must be spotlessly clean. Shredded plastic enters a friction washer, where high-speed paddles agitate the flakes in a mixture of hot water and biodegradable detergent. This removes any residual food, labels, glue, and surface oils. Now that the plastic flakes are clean, dry, and sorted, it's time to turn them into something new. Plastic pellets, the building blocks of nearly every plastic product made today. The flakes are fed into a twin-screw extruder, a long cylindrical machine that both heats and mixes the material. Inside, giant rotating screws push the flakes forward while raising the temperature to over 250 degrees 482 degrees Fahrenheit, hot enough to melt plastic, but not to degrade it. As the plastic becomes molten, it's forced through fine mesh filter screens that remove any remaining microcontaminants, like tiny bits of paper, glue, or metal. The pressure and filtering here are critical. One flaw could compromise an entire batch of food-grade product. The filtered plastic then exits the extruder in long, thin strands, often called spaghetti. These strands pass through a cooling water bath, solidifying as they travel along a moving belt. At the end of the line, a high-speed rotating blade cutter chops the cooled strands into uniform pellets, each no larger than a grain of rice. These pellets are then dried and conveyed into storage silos or packed into bags for transport. Each batch is sampled and tested for molecular weight, melting point, and impurity levels. Only pellets that pass these strict quality controls will be approved for use in food contact manufacturing. These tiny pellets are now ready to be reborn as packaging that protects, preserves, and serves. Next up, sheet extrusion, turning pellets into plastic sheets. With clean, uniform pellets now ready, the next step is to transform them into flat plastic sheets, the foundational material for making food containers. The recycled pellets are poured into the hopper of a sheet extrusion machine, essentially a larger, wider version of the extruder seen earlier. Inside, the pellets are heated once again to their melting point, typically between 220 to 260 Celsius, depending on the polymer type. With plastic sheets now cooled and rolled, it's time to turn flat material into a three-dimensional product, a food container you can actually use. The rolls are fed into a thermoforming machine, a precise system that combines heat, pressure, and vacuum to shape the plastic. First, the sheet is unrolled and passed through heating zones, where it's gently warmed to just below its melting point, enough to soften, but not deform. Once pliable, the sheet advances over a forming station, where it's pressed into molds representing the final shape: clamshell containers, deli trays, salad bowls, or custom designs. A combination of vacuum suction and compressed air pulls the sheet tightly into every contour of the mold, ensuring consistent wall thickness and structural integrity. This process can form dozens of containers per second, depending on the mold configuration. After shaping, the sheet moves to the cutting station, where sharp dies punch each container out of the surrounding excess material, known as skeleton trim. But nothing is wasted. The leftover plastic is immediately shredded and refed into the extrusion system, creating a closed-loop process that dramatically reduces material loss. At this stage, optional features like recycling codes, company logos, or custom textures can be embossed directly into the container surface. The formed containers are then stacked, counted, and conveyed for final sterilization, the last step before they're ready to hold real food. Before recycled containers can touch anything edible, they must meet one final standard: absolute cleanliness and safety. Freshly molded containers enter a UV sterilization tunnel where powerful ultraviolet light eliminates bacteria, viruses, and mold spores without using chemicals. For certain applications, steam sterilization is used instead, ensuring containers meet both FDA and EU food contact regulations. Next, robotic arms perform visual inspections, using high-resolution cameras to detect cracks, warping, or surface defects. Sensors also verify wall thickness and sealing tolerance. A random sampling of each production batch is subjected to stress testing, including compression, drop impact, and temperature resistance, simulating real-world handling from freezer to microwave. Only the containers that pass all criteria move forward. Those that don't are recycled back into the process. Clean, strong, reliable. These trays are now ready for packing, distribution, and their second life in your hands. From curbside bins to conveyor belts, from plastic flakes to polished trays, the journey of a recycled plastic food container is one of transformation, precision, and purpose. What began as discarded waste has now become something clean, safe, and useful. And thanks to modern recycling technologies, it can go through this cycle again and again. Each container represents more than just packaging. It's a commitment to circular thinking, to using what we have smarter, to reducing waste without sacrificing performance, and to reminding ourselves that every small decision, even what we throw away, can shape what comes next. In a world full of disposables, this is what renewal looks like. If you enjoyed this journey from trash to table, don't forget to like, subscribe, and tap the bell icon to explore more stories behind the things we use every day. There's always more to discover, right here on How It's Made.